So now let's think about forest. So now let's think about fires not on grass but in a forest. Now trees themselves, the trunks at least, don't burn. They've got far too much water. Even if they did burn, they wouldn't put off very much energy because their surface area is quite small compared to their mass. At least what tends to start the fire is small stuff, small twigs and leaves and bits of bark like you're seeing over here. This would burn very well, and if it does burn, it'll radiate a huge amount of heat very quickly because it's got a lot of surface area for its mass. And so it's this small stuff that tends to spread the fire. The fire can then catch in the big logs and they will burn for a long time afterwards, but it's the small stuff which catches fire first and generates the most heat most intensively and therefore spreads the fire the most. So in fact, you often have hazard reduction burns where fire is set to try and prevent future bigger fires, and the main goal of those is to remove the small stuff so that if a major fire comes through, there's less stuff that can burn so quickly and so violently. So a big log like this, it probably will catch fire, at least on the outside, but probably will burn more as embers rather than pyrolysis, and it'll burn for a long time. It can be a danger because it can restart the fire after the main fire front has passed. This is not going to be what spreads the fire. This will just catch as the fire front goes through, but it's not going to do a major contribution to burning down other things around it or to spreading the fire. Now, in areas with trees, forest or bush, a crucial distinction is whether the fire is on the ground or up in the tops of the trees. So a typical low intensity fire like this one, the fire is just on the ground, and these are not that dangerous. They're no worse than grass fires typically. They can still be dangerous and set things on fire, but the radiation is not that intense because even standing here, you can see that this is obviously taken probably by a firefighter, and the solid angle covered by flames is not that great. And you see some bushes and the trees have survived even as the fire has run through on the ground. What's the real problem is if the fire spreads to the tops of the trees. This is known as crowning. And this is where things become much more dangerous. You can see that the fire is now covering a much larger solid angle. Hopefully this picture was taken by someone with a zoom lens who wasn't actually that close to it. How does this happen? Well, one way it happen is if you've got fuel at a whole range of surfaces, heights. You might have surface fuel like leaves and twigs in the ground, then near surface fuel in small shrubs, elevated fuel at middle heights, and fuel in the bark of the trees and at the top. And if you've got fuel at all these levels, then you're in a really dangerous area because the fire can spread from here upwards until it crowns. And once it's crowned, the huge radiation will set fire to more trees of crowning and spread much faster. A lot depends on the level of middle level vegetation, also on the type of bark. If you had a tree like this with a dry, flaky bark, the fire can certainly spread up here, whereas a tree with a smooth bark like this one, it's not going to spread up so much. So this is a crucial distinction in forest fires.